morning everyone. Today we are discussing about fracture type and testing of materials. Fracture. Fracture is the separation of a body into two or more parts under stress. The applied stress may be tensile, compressive and shear or torsion. Fracture are classified into two types: brittle fracture and ductile fracture. The brittle fracture involves two steps: crack formation and propagation. The mode of fracture is highly dependent on mechanism of crack propagation. Brittle fracture takes place without any deformation and by rapid crack propagation in single crystals. Brittle fracture occurs by fracture along a particular crystallographic plane. The failure in brittle material was occurred by many micro or fine elliptical cracks in the metal. In this brittle fracture, it may occur in boilers, ship body, aeroplane and pipe lines. Next, ductile fracture is a plastic deformation in the crack propagation under tensile load. In this ductile fracture occur four steps. First one, neck formation. Second, formation of crack. Third, propagation of crack. And finally, shear fracture at an angle 45 degree to the tensile direction. In a tensile load, the neck formation first take place. After necking, small cavities are formed. Next, as deformation continues, the crack continues to grow in a direction parallel to its major axis. Finally, fracture occurs by the neck by shear fracture at an angle 45 degree to the tensile direction. The fracture having this type of surface termed as cup and cone fracture, because one of the matting surface is in the form of a cup and other is like a cone. Next, testing of materials. Tensile test, compression test and shear load test. In tensile test, one of the most useful tests applied to metallic material is the tensile test. In tensile test is conducted at room temperature by applying a gradual increased tensile load to a standard test specimen. To conduct the test, the specimen is gripped between fixed and moved heads of universal testing machine. It is the standard universal testing machine image. In the test, load is increased gradually and corresponding stress strain diagram is obtained with the aid of instrument attached to the machine. show this is a stress strain diagram for ductile material. Point 0 to A is elastic behavior region, and point A is indicate to proportional. The proportional limit, it is the maximum stress at which strain is directly proportional to the stress. And point B is elastic limit. It is the yield regions. The elastic limit, it is the maximum stress at which the specimen is deformed without fracture under tensile load. Point C is mentioned yield point. It is the minimum stress at which the specimen is deformed without an increase in load. And point D is indicate tensile strength. Point C to D is the region of strain hardening. The point D is indicate tensile strength, otherwise ultimate strength of material. It is the maximum stress that a metal can withstand without fracture under tensile load. And point E is indicate to fracture. The material is separate into pieces. The point D to E, the region is called as necking. Compression test. In this test, the stress increase rapidly. Here the end of test due to an increase in area of the specimen. The specimen selected depends upon the metal be tested. To determine compressive property, a specimen is usually chosen in which the length is 3 times the diameter. Shear test. Shear strength is the force required per unit area to produce fracture. When impressed vertically upon the cross section of a material, the method of testing both single and double strength. Impact test. Impact test is classified two types, isoid and Charpy test. Impact test is performed to study the behavior of materials under dynamic load. The capacity of material to withstand blow without fracture is known as impact strength or impact resistance. Is the image of impact test machine. Is the image of isoid impact test specimen. This is the image of Charpy impact test specimen. The impact test positions. First one, isoid. the specimen is vertically fixed to the fixture, and the pendulum will be giving a blow face of specimen, and Charpy test specimen is fixed to horizontally to the fixture. In impact test, the pendulum weight is raised to standard height, which has some potential energy. Pendulum is released, the potential energy is converted into kinetic energy. This pendulum hit the specimen, portion of kinetic energy is used to propulse the specimen, and pendulum rise to a height lesser than initial height. Difference in height multiplied by weight is the energy consumed by the specimen. The dial indication give direct reading. Thank you all.